Okay, look at this circuit. So this is one important question. Sometimes they have asked this switch debouncing. What do you mean by switch debouncing? And explain. You are supposed to write this circuit and you are supposed to write this waveform, and you need to explain the things. Switch debouncing with SR latch. What do you mean by switch debouncing? The same, the flip flop, the same circuit, the same circuit. They have just written like this. Both the S side and R side, both they have been grounded. And you can notice this A and B, this is like a switch hold. So if this is connected towards A side means R is equal to 1, if it is connected towards B side means S is equal to 1. When S is equal to 1, R will be 0, so that is what we call a set state. Q will be 1. When S is equal to 0, R is equal to 1, so that is what we call as reset state. Q will be 0. This is how this switch is going to work, like a normal switch, on and off. Okay, when this is off, R will be 0, so Q will be 0, means reset state. When it is on, when this arrow mark is connected towards the B side, S will be 1 and it will make switch on, so Q will be 1. This is how this switch is going to work. So when normally just imagine a switch at your home, switch on, switch off. Okay, when you off the switch, it will be in the 0 state. When you on the switch, it will be in the 1 state. It will be either in one of the state. Either it might be 0 state or it might be in the 1 state, not in the middle. Okay. So similarly, how this works when it comes to waveform. Okay. So right now S is equal to 0. Okay. R is equal to 1. So right now S is equal to 0. R is equal to 1 means it is a reset state. So Q is 0. Reset state means 0, right? So S is equal to 0, R is equal to 1, reset state, so Q is equal to 1. So when the, look at here, this is also 0, S is equal to 0 next. R is moving from 1 to 0 state, 1 state to 0 state. When the R is moving from 1 state to 0 state means it immediately don't switch from 1 to 0. It will take some bouncing. The circuit will bounce like this, low high, low high, low high, like this, 0 1 0 1. It will get bounce. It will get bounce before switching from 1 state to 0 state or 0 state to 1 state. Any switch, it might be S or it might be R. It will bounce like this before switching from 1 to 0. Okay, so that is what we call switch debouncing. Okay. So after bouncing, it will move from 1 to 0. So here S is equal to 0. When S is equal to 0, R is equal to 0, what happens according to SR latch? It will reset, it will retain its previous state or no changes will occur. What is the previous state? 0. It will be 0 state itself. Okay. So when S is, right now it is in the 0 state, it has to supposed to move to 1 state. Before moving, it will bounce like this and it will move to 1 state. When S is equal to 1, R is equal to 0, so the output will be 1, set state. Okay, this is switch debouncing. You need to explain the things. So, and this is an alternative form for SR latch which we discussed in this table. Okay, the same table, the whole table has been complemented here. The whole table is complemented. Rather than writing S and R, they are made S bar and R bar. Everything is complemented. So here 0 0 0, so there it will be 1 1 1, 0 0 1, there it will be 1 1 0, so something like that. Okay, so they have complemented these two columns, S and R. Okay, so obviously this also changes. So the same circuit also has been complemented, S bar and R bar, rather than writing S and R. See, here it is supposed to be Q and here it is supposed to be Q bar, but it is inverted. Here it is Q bar, here it is Q. Look at here. So here it is Q, here it is Q bar, because it is completely complemented. The whole circuit is complemented. The whole table is complemented. That's it. The alternative form of SR latch. Okay, I can tell you this alternative form of SR latch. Nothing much important with this. So the circuit might be like this also. They have just given an example. That's it. Okay, I hope you came to know about this switch debouncing with an SR latch, and this is important, guys. And So we'll deal with the gated latches next.